Hello students, some of the students are asking for the video of application of colloids also. So I have taken that video also, a very small video I am giving you today. That application of colloids, how the colloids are having different application in different fields. Here, like firstly I am taking medicine field. In the field of medicine, medicines are used in the colloidal form. Why? Because in the colloidal form, they can provide large surface area so that the germs get absorbed on them and get killed. Here I have taken some example like colloidal medicines are providing large surface area that I am telling you. Colloidal gold is used for intramuscular injections. This is very important students that why colloidal gold is used in medicine. So answer is since colloidal gold provides large surface area, thus it is used in medicine field. It is used as intravenous muscular injections. Next is milk of magnesia. I think that you are familiar with this milk of magnesia. Formula is MgOH whole twice. It is the main constituent of antacids. Like if you have heard about digen, gelocil, they all contain main constituent milk of magnesia, which cures the problem of antacid. So this milk of magnesia is also in the colloidal form. Yeah. So in this way, colloids can be used in the field of medicine. Colloidal gold, milk of magnesia. One argyrol is also there. It is a colloidal silver and it is used as eye lotion. Colloidal antimony, Sb is a symbol of antimony. Colloidal antimony is also there, which is used for the treatment of kala-azar. Kala-azar is a high fever. Okay, so in this way, colloids are used in the field of medicine. Next, I am taking next application is artificial rain. What is it? Artificial rain. Since you should know the phenomena which is taking place behind these all. So in artificial rain, coagulation is taking place. Have you heard coagulation? Coagulation meaning precipitation. Precipitation, what is happening? Converting colloidal solution into precipitate. That is called coagulation. We have done in the previous videos. Here, like clouds, if I am taking, clouds are the colloidal solution. That also we have done. So when the opposite charged electrolytes are sprayed over the clouds by helicopters, we can move up above the clouds, and if the electrolytes are sprayed over the clouds, that clouds precipitate in the form of artificial rain. So artificial rain is also an example of application of colloid. Okay. Next is delta formation. Again, coagulation is taking place. Deltas are obtained in the plains. You have studied in geography also, students in lower classes. So what happens actually if we are taking rivers, different rivers, they are flowing through mountains and they are having many salts in them. The rocks of the mountains are getting crushed and they are getting mixed with river water. So the river water is acting like colloidal solution, and ultimately all the rivers are meeting to the sea, and sea contain large number of electrolytes, salts in it. As these colloidal solution of river are getting mixed with sea, coagulation of this colloidal solution is taking place, and that coagulation is taking place in the form of delta. Delta is obtained when the rivers are meeting sea. Sea contains large number of electrolytes. So that electrolytes coagulate the river water in the form of delta. So this is delta formation. Next is the sky is blue. From the junior classes, One query is there in your mind that why sky appears blue, why not red, why not yellow? So as you know, friends, sunlight in the form of white light is coming into the atmosphere. It is containing Vibgyor, and the atmosphere is full of air. That air, atmospheric air, is also acting like colloidal solution. So atmospheric air is also acting like colloidal solution. So it scatter this Vibgyor, all the radiations. And which effect is taking place? Tyndall effect is taking place, scattering of light. And since blue color is getting scattered maximum, that's why sky appears blue. So this is also an application of colloids. And it is must soon that you have to write this Tyndall effect. In these concepts, you have to write coagulation. Clear? Now the next is smoke precipitation. Cotterell's smoke precipitator. This is also an important topic, students. As I was telling you in the previous video that from the industry, poisonous smoke goes out through chimneys. So many poisonous substances are present in that exhaust which is coming out from the industry. So what is done to remove that harmful substances? Charged plates are fitted in the chimney. Charged plates having high voltage current, having high potential. As this smoke moves through the chimney, smoke is also a colloidal solution. So as the smoke is moving through the chimneys, the harmful particles get coagulated, get neutralized on these charged plates and remain here in the chimney itself, and the fresh air moves out into the atmosphere. Thus, it is preventing pollution problem. And this phenomena which is taking place is electrophoresis or the cataphoresis. I have explained you this. Movement of charged particles of the colloidal solution towards opposite electrodes. Electrophoresis is taking place in this chimney. Cotterell's precipitator. Clear? Same electrophoresis take place in case of sewage disposal. Sewage, when disposed of, dumped into fresh bodies, what is done? Before dumping that into fresh bodies, it is passed through the pipes which are fitted with high voltage plates. Again, the same thing is happening. Electrophoresis is taking place because that sewage water is also acting like colloidal solution. Charged particles of colloidal solution are getting attracted towards these charged plates and getting neutralized. Coagulation is taking place, friends. Thus, they will remain here only, and the fresh water without harmful particles get mixed with the fresh bodies. Next example, this is very simple, student. Then also I have taken purification of water. In the purification of water, water contains some colloidal impurities in it. In that, we add alum. Alum, as you know, acts like loading agent. So what happens? Alum is the positive. Alum is providing positive electrolytes, and the negative colloidal impurities get neutralized, coagulated, becomes heavy, and settle down. And the fresh water is decanted out. So in this way, I have taken important applications, friends. Many more are given there. Just go through it. If you are able to understand these applications, that means you can able to understand the others also which are given in the book. So do it, students, nicely. And I have given you some questions related to surface chemistry that also you have to do in your fair copy, students. Okay, students. Thank you.